Alright, so in this next task, right, we continue with this potential new function. So let's take a look. It says, Marco has started a new blog about Sports Imagination High School that has decided to call iSight. He created a logo for the website that looks like this. Okay, so you have that I. Now, he is working on creating the logo in various sizes to be placed on different pages on the website. He developed the following designs. So you have size 1, size 2, size 3, size 4. So, how many squares will be needed to create the size 100 logo? And again, like, people always, wonder why we do things in math. Like, why is it important? And this is a prime example of where it is important. How do we calculate that quickly? Is drawing out to size 100 the best way and the most efficient way to do that? Absolutely not. The best way is to try and find the pattern and then determine how we can use the pattern or a rule to find the size 100 logo. So, with this, the first thing we're going to do is create that chart again like we normally do. X, f of x. So the size 1 logo had 3, 6, 7. The size 2 had, was that 5, 10, 12. This one has 14, 17. And this one would be 4, 22. So with this, right, we look at the pattern and we recognize, right, is it geometric, arithmetic, or the new type? Well, if I look here, right, what am I doing here? I know I'm not multiplying, but am I going up the same amount each time? And the answer to that is yes. This has a common difference of 5, which makes this an arithmetic sequence. And if it's arithmetic, let's answer number 2. Can we write the explicit rule for it? Yeah. Right? The explicit rule for this would be, I'm going to take one of the ordered pairs, right? 1, 7. I know my slope m is the common difference, which is 5. So we're going to say f of x equals 5 times x minus 1 plus 7. Now I could also write the recursive rule, so just let you know, you guys, that would be f of 1 equals 7, then f of x equals, we're going to do our previous term, x minus 1, right, and then plus 5. So when I look at this, you have your explicit, you have your recursive, but it's going to be easier to use the explicit to answer number 1. So now f of 100 would be 5 times 100 minus 1 plus 7, right, which would end up being 502 blocks. Okay? So as we continue, it says Marco decides to experiment with making his logo block here so that it looks stronger. Here's what he came up with. So now, when I look at this, right, x, f of x, when I make my table, size 1 has 1, 2, 3, 4, 5, 6, 7, right? Block, or size 2, you have 2, 4, 6, 8, 10, 12, 24, right, 28. And the next one, you have 1, 2, 3, then 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So that's 27, 54, right? And then 9 would be 363. Now, the questions here, right, are asking, number 1, assuming Marco continues this pattern as it has begun, draw the next figure, right, for size 4, right? Now, I'm going to go ahead and draw a size 4, alright, but I would like you to pause the video first and you try to draw a size 4. So if you go and draw a size 4, this is what you should get it to look like. And how many blocks would be in this figure, right? So if I look here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 by 4, which would be 48, right? Times 2 plus 16. So that one would have 112 blocks. Okay, so it'd be 4, 112. So now the next question says develop a mathematical model for the number of blocks in this logo size. Now, this is where it's tough. What I want you guys to pay attention to here is there a pattern here? Like, to go from 7 to 28, that means I went up 21, but from 28 to 63, did I go up 21? No. I can multiply 7 by 4 to get 28, but is 28 times 4 going to give me 63? No. Right? But what I'm going to do here is I'm going to do 28 minus 7, I'm going to get 21. Okay? Then I'm going to do 63 minus 28, and that's going to give me 35. Then I'm going to do 112 minus 63, which is going to give me 49. Now what happens here, right, is there's still really no pattern, right, other than now what we have here is a second common difference. What is the difference between 21 and 35? 14, right? What's the difference between 35 and 49? 14. Okay? Now, where this is going to lead is to a new type of function, right? And what we call this is a second common difference. Okay? It's a second common difference. Anytime this happens, this is how you get the new type of function. So what are we going to learn to call this? Well, let's come up with a rule for this situation first. Okay? If I look here, right? Actually, let's take a second to go ahead and I want you guys to try and figure a rule out on your own. Okay? Then I want you to be able to try and explain what you got for your rule. Okay? So, some of you may have seen the pattern where in the size 1, you have all of these square blocks, right? And how many of them do we have? Right? I have 7. Okay? Now, if I look at a size 2, if I look at this, I'm going to break this up into all the 2 by 2 squares that are in the diagram. And there is an even number, well, not an even number, but there are 7, right, 2 by 2 squares here. And if I look at this, now in size 3, I'm going to break this up into 3 by 3 squares. Okay, so I'm using this diagram to see that each of these sizes can be broken up into 7 squares, right? So this has 7 squares, right, that are 1 by 1, so they have an area of 1, and didn't that give me 7 blocks? What is the area of this? Or if I think about it, if I do 2 times 2, that gives me 4 blocks, right? And how many blocks do I have here? 7. So 7 times 4 blocks in each square would give me 28. Over here, size 3, we have a 3 by 3, which means each of these squares has 9 blocks. And if there's 7 squares, 7 times 9 is 63. Does that work for this one down here? Well, size 4 is 4 by 4, which is 16 blocks, right? 7 times 16 squares, or 16 blocks in each square, that would give you 112. Well, if we think about the size of a square, or the area of a square, so when we look at this, we say the area of this square is 16, right? So what do I do to find the area of a square? Well, if I told you this square had sides x units long, right, what would the area of this be? All I'm going to do is take x and multiply them together to get the area of that square is x squared. So when I go to find the function rule, or a rule for this function, right, the area of one square is basically the number size, right? So when I was looking at size 3, right, the area of this square was 3 by 3, so it's just a size squared, right, or size times size. Now, here's the thing, that's for one square. How many did these figures have? I had 7 squares here, 7 squares here. So, when I look, it'd be 7 times whatever size we're working on, right, to the second power, right? Or you could look at this as 7 times the side times the size, sorry. So, when I look at it, the best rule to give here, if it's a size n figure, that means it's an n by n and the area would be n squared. So f of n is equal to 7 times n squared. And that would be a rule that you can use for this. So if I told you to find the number of boxes in a size, let's go 10 logo, that would be f of 10, which would be 7 times 10 squared, which would be 700 boxes. Okay, now the difference here, right, is the first logo at the very beginning, right, if I had to compare it here, these grew in a linear fashion because we had an arithmetic sequence, right? So the first one, right, was arithmetic. So task 1 was arithmetic, whereas task 2 ended up being this new function. And the new function we're going to call is a quadratic function. Okay? So when we look at this, we know arithmetic has, right, a common difference. Okay, we know exponential or geometric has a common ratio. So what about this new quadratic function? We're going to call the third one. All right, what this has is a quadratic function has a common second difference, right? So when I look at this, a quadratic function, when you talk about the explicit rule, the explicit rule would be f of x equals some number times x squared plus another number times x plus some constant. Now the only part that makes this quadratic is this x squared part. Okay, and when we talk about second common difference, right, as I go back up here, if we find the common difference, it's not the same. But if we go and find the second common difference, these end up being the same. And as soon as you get a pattern with the second common difference, you know it's going to be quadratic. Okay, so I'm going to actually have you guys do the next task as a homework assignment. And then I will go through it, right? But I want you guys to see how you do on your own with it. Okay, so I'll post the next task. Get it done and then come watch the video to see if you did it right.